Welcome back to another one of my integration examples videos, where I basically run through examples of integration. I run through examples to show you how they're done and how to solve them, or how I would. This is the seventh episode. Each episode gets increasingly harder, or I just add different techniques in. The reason I usually have 3, but the reason I have 2 is because I'm doing both of these are by parts, and by parts takes time. So I figured I wouldn't want this video going for 20 minutes. Hopefully it doesn't go for 20 minutes, but I'll finish up this intro. So we'll start with 1 and then we'll do 2. Okay, so I'm going to use a sort of Lagrange's way of doing things, but it won't be a proper notation. So we're going to have example 1, where fx equals ln of x on x to the power of 3. So we find the integral of both sides, and I'm going to split this up. So we have ln of x multiplied by 1 on x to the power of 3 dx. Okay, this will be because we're going to be using by parts, because if this is let me find my words. This is a function times a function, and if we differentiate one of these, will it help get rid of the other? And the answer is no. So we're going to use by parts to solve this. So by parts. Usually, if you're doing an exam or whatnot, you signify by parts, or if someone else is looking at your work, so you can tell them what you're doing. Okay, so what I'm going to do is, the by parts formula is as follows: f multiplied by g dash dx equals f multiplied by g minus the integral of f dash g dx. Some people don't write the dx, some people put f of x and g dash of x, but I'm just going to write it this way because this is the way that I find easiest to understand and quickest. But so this is what the formula is for by parts, okay? And essentially we want this bit to look like this, because the integral of this is that. So if we make this here look like this, then we can find the integral of this using this. Anyway, so here we have an f and we'll have a g dash, and we need an f dash, and we need a g. Okay, so here we'll call, generally, whichever one's easiest to derive, you put as f, because when you derive it, it simplifies. But in some cases, for the g dash, you don't want to put something here that if you find the integral of it, it'll make it really complicated and a pain in the bum. So the ln of x will be a pain if we put it here. This will be easy to derive, but this will be a pain if we go to find the integral. So short story, I'm going to put this as f, and I'm going to call this as g dash. So ln of x will be f, and g dash will be x to the power of negative 3, because x to the power of negative 3 is the same as 1 on x cubed. So the derivative of f, I should say, is 1 on x, and the integral, you add 1 to the power and divide by the new power, so that'll be x to the power of negative 2 on negative 2, because you add 1 to negative 3 and you get negative 2. This will end up looking like 1 negative fraction 1 on 2 x squared. Okay. So if we essentially, we said that this up here was this, so I'm going to write it as such. So we're going to have the integral of ln of x multiplied by 1 on x to the power of 3, which we want to look like this, will equal f ln of x multiplied by g, which is multiplied by negative 1 on 2x squared, minus the integral of derivative of f, we said that was 1 on x, multiplied by g, we said that g was negative 1 on 2x squared dx. Okay, so now we've filled it in, we've got something to work with, we'll start solving. So this bit will just simplify to negative negative ln of x on 2x squared, and this bit, find the integral of, well, here we'll have to bring, I don't know if you can see it, but I'll just write it out anyway, makes sense, I won't gibberish too much. X multiplied to there, that's 2x cubed, because x multiplied by x squared is x cubed dx. I was going to skip a step, but it's probably just easier just to do it this way. So we have negative ln x on 2x squared plus a half the integral of 1 on x to the power of 3 dx. Now what did I do? Well, essentially we have a 1 on 2 constant multiplied to this 1 on x to the power of 3 constant. So I brought that at the front. We also have a negative, so I brought that at the front too. So a negative half multiplied by a negative is a positive half, if that makes sense. Hopefully it does. Okay, so we have negative ln x over 2x squared plus a half. We said that the integral of x to the power of 1 on x to the power of 3, we had it up here, was negative 1 on 2x squared, negative 1 on 2x squared plus c. Okay, so what I'm going to do now is just expand this out, and we'll get negative ln of x on 2x squared minus, that'll be 1 on 4 x squared plus c on 2. Okay. So that means that first what I'm going to do here is to make this a 4 so it has the same denominator, I'm going to multiply it by 2 on the top and 2 on the bottom. So that'll look like negative ln x, put the 2 there, over 2 multiplied by 2 is 4, x squared minus 1 4x squared plus, I'm just going to say over here that h equals c on 2. That way I can just put a h here. And now we have this, we can finally finish. So the integral of ln of x on x to the power of 3 dx is equal to negative 2 ln x minus 1 on 4x squared, and then a plus h. Okay, now I'm going to get, that's the answer right there, and I'm going to get right onto the next integration by parts, because this is already up to 9 minutes. Okay, so let's get on to our second example. Try and make this a bit quicker. Example 2. fx equals x multiplied by cos x multiplied by sin x. Okay, so as usual, find the integral of each side. There's a rule which states that it says sine 2x, it's just the trig identity, equals 2 multiplied by cos x sine x. You can rewrite this by dividing both sides by 2, which will cancel these out, and you're just left with basically sine 2x on 2 equals cos x sine x. Therefore, where we have a cos x multiplied by sine x, I'm just going to input this, which will look like integral of x multiplied by sine 2x on 2 dx. Okay? So I'm going to use, well, first I'm going to bring the constant out the front, so it's going to be a half of x sine 2x dx, and I'm going to use integration by parts. Now, because we don't have an ln or a number to the power of x, or we don't have an inverse trigonometric function or anything too complicated, I'm just going to make this one f, because that simplifies easy, and I'm just going to make this one g dash. I already wrote the formula up before, I'm going to write it up again though. F multiplied by g dash dx equals f g minus the integral of f dash g dx. Okay, so we're going to need an f value, we're going to need an f dash value, a g value, and a g dash value, or a function. So f we've said is x, the derivative is 1, we said g dash was sine 2x, the integral, I'm not going to put the plus c here, but the integral of it would be cos 2x on 2, and then a negative. Because I'll leave that formula up, because the integral of sine is negative cosine of 2x, and then you have a divided by 2, because I could solve this, but it'd be much easier to explain it, because if I was to derive this, you would turn this negative cos into a sine, and you'd leave the 2x the same, but because it's the chain rule, you would multiply by 2x. So if you were to derive this, multiplying by 2x would cancel out the bottom 2x, which would leave this. So basically all you need to know is the integral of this is that. So let's fill it in. So our original function was, well, we have a half, but I'm not going to worry about that just now. It's x sine 2x. This is the function we want to find the integral of. And that equals f, which is x, g, which is negative cos 2x on 2, minus the f dash, which is 1, so we don't care, and then g, we said, is negative cos 2x on 2. Okay, so now we have our function, or our equation, something we can work with. So here we're just going to have negative x cos 2x, just multiplying the x in, on 2, and we're going, here we have, essentially we have a negative 1 over 2 multiplied by cos 2x. So I'm going to bring this negative 1 over 2 out the front. Negative times a negative is a positive, and have a half, and the integral of cos 2x dx. Okay. Negative x cos x, or cos 2x, 2, plus a half. Now, just like before, when we had sine 2x and it went to this, we're just going to do the exact same for this. So it's going to be, it's going to go to, it's going to go to, the integral of cos is sine. So sine 2x, sorry I had a mind blank for a minute, on 2, plus c. Now, I could do integration by substitution, but hopefully you can see it, because if I did integration by substitution, it would take forever, and it's not that, at this stage of doing differentiation, it's not that integration is not that difficult, because you have sine 2x over 2. If I wanted to get to this, if I derived it, I would bring the 2 out the front, which would cancel the 2's altogether, and you'd be left with sine 2x, and then I'd derive the sine, which would give me a cos, therefore I'd be left with that. So if I derived this, I would get that, basically. So next step, we just write this out again. Plus, multiply a half in, so a half multiplied, 2 multiplied by 2, we're going to have sine 2x on 4, and then so we're going to have on 4 plus a half on the c, so that's going to be c on 2. Okay. Now that's going to equal negative x cos 2x on 2. Now what I'm going to do is I'm going to multiply this by 2, which will make this a 4 because I'll be multiplying the bottom by 2 as well. So it'll be negative 2x cos 2x on 4, that's about 4, which means this has a base of 4, so I can continue this on and put plus sine 2x. So they both have the same denominator. And here I'm going to put plus 2c, so that will be on 4 as well. Because 2 times c will be 2 times 2, which will be 4 denominator. It's all over 4, basically. I've made it so it's all over the same 4. Okie dokie. So now, here's our answer for the integral of x sine 2x dx. But that's not what we originally asked. We originally asked for x sine 2x on 2. Okay? So there was a sneaky little half out here that we got to multiply back in. And essentially, if we put the half here, we have to put the half on this side. So I'm going to rewrite that. So we're going to have a half multiplied by the integral of x sine 2x dx. That's what our integral of our original function was supposed to be. Now we have this. We basically sub this whole lot of mumbo jumbo into this. So we're left with, I'll just flip them back, and we'll have fx equals half multiplied by negative 2x cos 2x plus sine 2x plus 2c all over 4. Okay, so we just have a 2 multiplied by 4 basically on the bottom. And I'm going to rearrange this in one step. Have a sine 2x negative 2x cos of 2x plus 2c all over a half multiplied by a quarter is an eighth. Therefore, integral of this function up here is this. Now, thanks for watching this video. I hope you learnt something and hope you have a good day.